Hello friends, once again this is Jury Tech Clinic, and if you want to learn electronics repair, motherboard diagnostics, now this video is extremely important for you. And today we are going to learn on how to use a digital multimeter. This component is small but very basic and very important for electronics technicians. So if you are dreaming about becoming an electronics technician, you must learn on how you can use this important tool. Yes, the name suggests digital multimeter. It is a multimeter because it is used to measure a lot of electrical parameters such as voltage, resistance, current, continuity, and other parameters. Let us try to see some basic parts of our digital multimeter. We do have this screen, and this is the one which is used to measure the value of our parameter. But also we do have this diode selector. This is the one which is used to help us select what we want to measure, whether we want to measure voltage, whether we want to measure resistance, or we want to measure current, as you can see. But also we do have these probes. As you can see, we do have this port here that is black, as you can see, and it's labeled CHROME, and this is where the black probe should stay. This is a negative probe or the ground probe. But also we do have these two ports. The first one is used for measuring voltage, current, continuity, and resistance. But this one, as you can see, it's labeled 10 ampere DC. So this one is used for measuring high voltage, or it is used for measuring the electricity with the high current. Yes, this one which is labeled 10 ampere DC, it is used for measuring a high current. Therefore, it is recommended for beginners to use these two ports, the black port, as you can see, and this one which is used for voltage, continuity, and current. Yes, there are some other parts, like here you see this backlight for my multimeter, but in some of the multimeter this is not present, so this is just optional. But also we do have this button labeled H. This is for holding some readings, and this is optional, not present in all parts of all multimeters. Now let's go direct and see how we can measure different parameters using our digital multimeter. As you can see, when it's look like this, means our digital multimeter is off. Now we can choose whether to go in this. You can see a labeled this symbol V. This is a voltage, but remember we have two types of voltage. We have voltage from direct current and the one from alternating current. So this means the DC or direct current voltage. It has this symbol. But also we have another V, this one. This means the voltage from alternating current. But also we do have this symbol here, as you can see. This is the symbol of resistance, and it is ohms. So as you can see, we do have we can measure different ohms from 200 to 2 million ohms. So we can select according to the quantity or amount of ohms we want to measure. But also you can see here we do have A. This means ampere, and we can measure 200 microampere to 10 amperes. But also you can see something like a bell here. This can be used to test continuity, and we are going to see how we can do all these testings. Without wasting time, let us check how we can measure the direct current. I would like to remind you that most of the sources of direct current include adapters, batteries. All these produce the direct current. Also you can see I have my DC power supply. This produces direct voltage. So we can see how we can test we can measure the voltage from direct current sources. Yes, as I have told you that one of the important source of DC voltage is laptop charger, even the mobile phone charger and the batteries. All of these produce DC voltage. Now imagine I want to test my adapter whether it's okay or not. So what I'm supposed to look is to check the outputs, whether it produces the required voltage or not. Now, how do I know how many volts are supposed to be produced by this adapter? You can check it by reading from your adapter. Example, if I can read on my adapter, I can check on the output voltage. I find that this adapter Suppose I want to test whether my DC adapter is okay or not. This is the laptop charger, as you can see. So I want to check whether it's okay or not. What I supposed to know is to understand how many volts are produced by this adapter, and I can see it by reading. So if you cannot see clearly, you can just check your charger and then read it. As you can see in the option of the output, my DC adapter produces 9.5 volts with 2.31 amperes. Therefore, if I test on the output of this adapter, I should get 19.5 volts. See? So let me test whether my PC adapter is okay or not. First of all, I need to understand this adapter produces DC voltage or AC voltage. As I said earlier, this produces DC voltage. Therefore, I'm going to set my multimeter in the DC voltage mode. Mind you that this DC voltage mode from our multimeter, as you can see, it measures 200 millivolts, 2 volts, 20 volts, 200 volts. Therefore, if my adapter produces 19.5 volts, it means the best option to set, I can set it to the 20 volts or 200 volts. Let me set it to the 20 volts. And then I will take my black probe. As you can see, this one, as I said, this mostly stands for the negative probe, and this for the positive probes in case of the DC voltage. Therefore, I will set my DC probe to the ground of my charger, or the negative of my charger, and then I will test this red probe on the positive side of my charger. You see? Yes, as you can see, I get the readings of 19.82, that's approximately 19.5 volts as I've been told for my adapter. Therefore, my adapter is okay because it produces 19.5 volts DC. Another thing you need to understand is that the DC voltage has a polarity. It means that it has a positive and a negative, and our multimeter can tell whether the polarity, whether it's positive or negative. Example, if I vice versa the polarity, I put the red probe on the ground and the negative probe on the positive side of my charger, what will happen? You see, it gives me an indicator. What it shows me is that I made the vice versa. So it means I should return these points in order to know the exact polarity. So if you are making some testing and then see it puts negative when you are trying to test the DC voltage, it means you have vice versa the polarity. So you can read the polarity in that way. So if I'm trying to test in this way, I put my black probe to the ground and the red probe to the positive. As I see a 19 and there is no negative symbol, it means the polarity is okay. As we have a lot of DC sources, as you can see, this is my DC power supply. So still I can test. As you can see, this DC power supply produces 19.5 voltage. So I can test it with my multimeter. I can test it how many volts are coming here. You see, I get 19.49 volts. So this is how I can test whether my DC power supply works or not. Going to the another side without wasting the time, as we have said, this is alternating current voltage, AC voltage, as you can see. So we can set a multimeter to this side. As you can see, this is the side of the alternating current voltage or AC voltage. Remind you that most of the sources of AC voltage are from our wall sockets. The wall sockets produce AC voltage of around 240 volts. So, example, if you take your adapter this way, you can find this power cable. So this power cable always produces AC voltage that goes into this adapter, and this adapter converts AC voltage to DC voltage, which is usable for your computer. So I can test the AC voltage coming from this power cable, and most of wall sockets produce around 220 volts to 240 volts. So let us check. As usual, I'll put my selector to AC voltage. Mind you that the AC voltage has no polarity. It has no positive, it has no negative. So whether I vice versa the probes, it's okay. So I will set my probe in one of the point and the second probe on another point. As you can see, I get some readings there. I get 228 volts. These are AC voltage. So this one goes into the adapter, and my adapter converts this 200 20 volts into 19.5 volts, which are to be used by my laptop. Avoid one mistake here, guys. While you are measuring AC voltage, especially high voltage like this one, make sure that you are careful so that you don't touch these probes together, as they can cause short circuit. This 220 volts with 1.3 ampere volts is so high, so if you can touch them together, they can cause a short circuit. That's really dangerous. Another important part, guys, is this one, the continuity. This is one of the important part that is used to detect short circuit, but it is used to detect a lot of devices, whether they are okay or not. So let us put our multimeter, this selector, to continuity mode. This continuity mode helps us to understand whether the wire or any device has a continuity, or it allows the electricity to pass through. So if there is a continuity or there is a closed circuit, our multimeter will beep. Like here, you see it beeps. It indicates that there is a closed circuit, there is a flow of electricity. So if I take a liquid wire, let's say, or a point that does not transfer electricity, it means my multimeter won't beep. Like this, these points don't transfer electricity, so my multimeter won't beep. So it shows that these points don't transfer electricity. So when I take any material that transfers electricity, like this one, then I test them on my multimeter. You see, yes, it beeps because this device has the ability to transfer electricity. So this continuity mode can also help us understand if the material has the ability to conduct electricity or no. In simple, it can help us to differentiate between insulators and the conductors. Apart from that, the readings from this continuity mode have different meanings, so they can help us understand the value of the ohms of different parameters. So we shall be measuring different parameters using this option, and it will have different implications. As you can see, we do have also this sign, and this sign is the sign of ohm. This is the unit of resistance. So we can measure resistance of our devices by selecting it to this side. So we can measure the resistance of resistor, of coils, of transistors, and other semiconductors by using this side. Example, I do have my laptop motherboard here, and I'll try to find one of the resistor and measure its resistance. As you can see, this one of the resistor, and if I measure it, it reads 6.5 or almost 6.2 ohms. Therefore, that is the value of the resistance of my resistor. It's 6.2 ohms. There's a lot of options, guys. As you can see, we can measure 200 ohms, we can measure 2k or 2000 ohms, but also we can measure 20,000 ohms. We can also measure 100,000 ohms up to 2 million ohms, because there are some of the devices with the high resistance. Yes, we have another part, and this is labeled A. A stands for ampere, and this is SI unit of current. So as you can see, we do have 20 microampere, we do have 2 milliampere, 20 milliampere, 200 milliampere, and 10 amperes. I would like to remind you guys, for us to measure the amperes or the current, there must be a closed circuit. We cannot measure current in an open circuit like this one. That's why you see my DC power supply shows 19.5 and 0.0 ampere, because there is no closed circuit. There is no any device that's drawing current from my device. So for us to measure the current, there must be a complete circuit. We must connect a device that consumes the electricity or consumes the current, so that we can measure the value of current. I hope, guys, you have learned something, and we shall keep producing a lot of videos for education like this one. What you need to do is to subscribe to our YouTube channel so that you can support us and level up your skills today.